Welcome. In this video, we are going to take a look at problem 36. It is from chapter 31 of College Physics 2E by OpenStax. In this problem, we need to write the complete alpha decay for the given nuclide, and then we need to find the energy released in the decay. All right, so let's start with what we know. Okay, we have 249 CF, so that means our A is 249. It's our mass number. From the chem table, we see Z is 98, so 98 protons, and CF is californium. All right, and so we know that A is the number of protons plus the number of neutrons. So the number of neutrons is going to be A minus Z. And so we've got 249 minus 98. And that gives us 151 neutrons. All right, so we'll do part A. So we've got the alpha decay equation. Okay, and so we have A, Z, nuclide X with N neutrons. This goes to A minus 4, Z minus 2. We've got our Y and N minus 2. And then plus the helium for 2 He2, helium nucleus. Okay, and so we're going to start off with A is 249. We looked up Z, number of protons is 98. We have CF, and we calculated 151 neutrons. Okay, we're going to decrease A by 4. That's going to make it 245. We're going to decrease Z by 2, so that's going to 96. We look up 96 on the chem table, and it is Cm. And then we're going to decrease the number of neutrons by 2, so that's going to go to 149. And then we have our alpha particle, which is the helium nucleus. We've got 4, 2, He, and 2. All right, so that is the decay equation. Now we need the energy released. Okay, so we're going to use energy released is going to be the mass defect, which is delta M times C squared. All right, so let's go find the mass defect delta M first. And so we can use this notation. We need the mass of 249 CF minus, then we need the mass of 245 cm plus the mass, and I didn't get the parentheses in there, but that's okay, of 4 helium. Okay, and these need to be looked up. Appendix A of the textbook has them, and we need to use all the digits they give us. Okay, and so californium is 249.074844 atomic mass units. Okay, Cm is 245.065483. And then let me take away that parentheses. Then we need to add in the helium, 4.00 0.2603. All right, so I calculated this and I got 0.0065758 atomic mass units. Okay, and so now E mass defect times C squared. Okay, our mass defect is 0.006758 U's. And now we have a conversion factor, and it is 931.5 mega electron volts per C squared per U. And then we multiply by C squared. So the C squareds cancel. We don't need to put in the values. So that's the energy. And so the energy that is released is 6.295 mega electron volts. And so to 3 sig figs, we can call that 6.30 mega electron volts. And that was everything we needed to find. I hope that was helpful. Let me know in the comments section if you have any questions. Thank you for watching, and I'll see you in the next one.